Yeah. So in this program, our main aim is to plot the lowest four wave functions. Lowest four means for n is equals to 1, 2, 3, and 4. Probability distribution and eigenvalues for a particle trapped in 1D box. So along with it, we have to find the probability of finding the particle between L by 4 and 3L by 4 for n is equals to 1, 2, 3, 4, and expectation value of the particle between 0 to L and minus L by 2 to L by 2, right? So starting with the program. So first of all, we have to define the variables. Variables, or you can say the values. So we are taking L as 10 nanometer, that means 10 into 10 raised to power minus 9 or 10 raised to power minus 8. So here L is the width of the potential well. Okay, and H is our Planck's constant in joules. M is the mass of electron in kgs, and A is the another quantity which we defined as the square root of 2 by L. If you want to define it like that, you can do that. Otherwise, you can directly put square root 2 by L instead of putting A in the formula, right? And we will be defining x is equals to 0 to L by 128 and L. This x will be useful for plotting the wave functions and eigenstate. For plotting the eigenvalues, we will be taking a different range of x. So we will see that there. So first of all, for determining the probability of finding the particle between L by 4 and 3L by 4. So if we want to do it for n is equals to 1, 2, 3, and 4. So for that, I had two options. Either I define n is equals to 1 here, then put the same form, then calculate the same for n is equals to 1, and then I put the another variable, and then I took n is equals to 2 over here, then 3, and then 4. So to shorten my Scilab code, so instead of taking n is equals to 1, then 2, then 3, then 4, I use the for loop in which I define that you will be finding the probability for n is equals to 1, 2, 3, and 4, and print the same for us. Okay. So here I define variable PF as probability of finding the particle. So to so the formula for probability of finding the electron is a square sine n pi x by L whole square. And we integrate this with respect to dx over the limit of L by 4 to 3L by 4. So in this, L by 4 is our lower limit, 3L by 4 is our upper limit. This is the function which we want to integrate in order to find the probability, and we are integrate it with respect to x. So to integrate this value in Scilab, I have to use the command called integrate. Okay. So in this integrate, I define, first of all, I define the formula that this is the formula, this is the function which I want to integrate, and then I define in which respect I want to integrate. That means if I want to integrate it with respect to x, so I choose x here. So L by 4 is the lower limit, and 3L by 4 is the upper limit. That means I want to integrate this function with respect to x from L by 4 to 3L by 4. Okay. And to print those values, I use the command printf. So in this, I wrote the probability of finding the particle between L by 4 and 3L by 4 is when n is equals to percentage f is percentage f. So I define percentage f over here, and over here. So what does it mean? So when n is equals to percentage f, it will take the value of n from here and put it over here. Like for n is equals to 1, for n is equals to 2, for n is equals to 3, and for n is equals to 4. So instead of using the printing or display command over and over again to print the print every value, we use the print command, so that it will take n is equals to 1, 2, 3, 4 by its own, and is percentage f, and in this second percentage f, it will enter the pf value which you have calculating using the integrate command. Okay, so for n is equals to 1, when n is equals to 1, then pf is this. For n is equals to 2, pf is this. So and so on. And in the similar way, to integrate this formula for the to determine the expectation value, which is the x into a sine n pi x by L whole square with respect to ds over the range of 0 to L. So again, we will define E as the expectation value. You can use any other variable of your choice. So I am using E for my simplicity. I will be using the integrate. Then I will be putting the function which I want to integrate. I will be putting in which respect I want to integrate. Then lower limit, then upper limit. And in the same manner, if I want to find the expectation value for minus L by 2 to L by 2, so instead of putting 0 as lower limit, you will be going to put minus L by 2, and instead of putting L, you will be adding plus L by 2. And then I will end the for loop, because my work for the for loop is done here. So now I have to print the expectation value for the particle between 0 to L, and for the particle between minus 2 to L. And in these commands, I did that. Okay. And now you are wondering why I use 1 here. Okay. So while calculating the expectation value, so the expectation value is going to be same for n is equals to 1, 2, 3, and 4. So instead of displaying all the same values, I choose 1, so it will be displaying only a single value for me. So from here, so by now we have plotted the, I mean, we have displayed the values or find the values for the probability and the expectation value over the given ranges. And now our job is to find the eigenvalues for the different values of n, that is n is equals to 1, 2, 3, 4, because we are given that we are determining this for first lower four lower values. So we know that the eigen energy values is equal to n square h square upon 8 ml square, right? So for so as I have earlier mentioned, I will change the range of x to plot these values. So I will take x1 as 0 to L by 4 to L. Again, I am using the loop to find the E, where E is equals to n square h square 8 ml square. So for plotting here, I have used if else loop. So why I did that? Because for the presentation of the graph, I want to scale different lines for different values of n. So I use if else. If you plot all these things in the for loop, so that's okay for you. That's also the convenient thing. So I use if else here. So what does it mean? If n is equals to 1, so it will plot eigenvalue for n is equals to 1 over here, and it will be giving me a black line plot. Okay, and line width is to define the width of the line. So I am telling, if n is equal if n is equals to 1, then give me the plot in which x1 by L will be by x-axis, and e by 9.666 into e raised to power minus 9 as my y-axis, and define this plot by a black line in which the line width is 2. So now why I use here x1 by L? Because in the plot we have to normalize the function. Normalizing means the scaling the values between 0 to 1. So if I divide x1 by L, so in this range I have highest value is L. So L by L will be giving me 1. So I use this over here. And in the similar value, I also have to normalize the y-axis. So I divided E over this quantity. Okay. So if n is not equal to 1, then what will we do? So I use else if n is equals to 1, then this will work. If n is equals to 2, then this plot, then it want to plot like this. It will follow this command of plotting. And in the similar value, for n is equals to 3, it will follow this. For n is equals to 4, it will follow this this pattern. So in and then I will be ending our if else loop, because after that I won't need the if else loop. And now, because I need x label and y label common for the this particular loop, so I will defining x label as this. This dollar sign is used for the mathematical expressions. So it will be giving me the mathematical will be writing the x-axis in the form of the mathematical expression or the mathematical font type. And I am keeping the font size f as 5. And in the similar way, I will be using the y label to defining the y-axis, and in the title, I will be giving the title to the graph. And I will be keeping the font size as 5 for all for the better visibility of the graph. And legend is used to define the various lines. Like if I use black line for n is equals to 1, then it will be, specify me that the black line represents n is equals to 1. The blue line represents n is equals to 2. The purple line represents n is equals to 3, and so on. So legend is used for that. And from now, the work for my for loop is also end. So I will end the for loop here. So in this manner, I have plotted the eigenvalues. Now, if I want to plot the wave and probability density functions, right? So I have the formula for wave function as psi is equals to a sine n pi x upon n. Okay. See, now I have used f1 is equals to scf1. See, this is to separate the graphic window, like so that the different graphs won't overlap. It will be creating a new window for me to plot this wave and probability density wave function. And again, I use for loop because I want to determine for n is equals to 1, 2, 3, and 4 over the huge range of x which we have defined earlier in the starting. So I defined psi is equals to a sine n pi x upon n, like this formula. Okay. And psi mod square is equals to psi square. So psi mod square is equals to psi square. So psi is our wave function and psi square is our probability density wave function which we have defined in the program. So for n is equals to 1, 2, 3, and 4, these values will be calculated. Okay. And now to plot this value, I have first of all used the subplot command. Okay. So for this subplot command, I have subplot is for the separated things. Like for n is equals to 1, I will have a different graphic figure. For n is equals to 2, I will be having different graph figure, and so on. And 2, 4, and n plus 4. Okay. So here, if I show you the results, so 2 is to 2 rows and 4 is for 4 columns. Like in the first you will be defining two. We are using four. We want two rows. In the second, we are you will be defining the column. So we want four columns, and n plus four is equals to c. If n is equals to one, then n plus four is equals to 5. So it will be taking 5, 6, 7, 8. So for this 5, 6, for this subplot 5, 6, 7, 8. That means for this 5, 6, 7, 8. It plotted my graph for probability density functions. So in the x-axis I have defined x by l. In the y-axis I have defined side mod by 2 is to power 8. The division factor is for the normalizing, and the see I want to see my graph in the red line, so you can use the color of your choice. And I have defined line width as 2. I have given title to the graph, x label, y label. This is the math, and this is for defining the psi x. Okay, so and for plotting the wave function, so I have used subplot 2 for 1, 2 for rows, 4 for columns, and it's like n 1, 2, 3, 4. So for 1, to at position 1, 2, 3, 4. So it will plot my side, that means wave function for me. So in the x-axis I have defined x by l, then in the y-axis I by 15,000, then I use the line blue and took the line width as 2. Give the title, give the x label, give the y label, and then ended the for loop. Now it's time to see what results we got. So yeah, this is our results. So I use the print command for printing the probability of the finding the particle between L by 4 when n is equals to 1, n is equals to 2, n is equals to 3, n is equals to 4. See, now the problem here is that after 1, we don't want these must 0 like this. So in the program, it's instead of writing percentage f, you will write percentage 0.0 f. So it writing 0.0 means you will be eliminating all these zeros from there. Okay. So yeah, and is so the probability function value which it calculated using the formula and the commands we have given is these. Okay, and the expectation value is this for 0 to L, and expectation value for minus L by 2 to L by 2 is 0, right? So that was our results related to the probability and the expectation values. And now we will be moving forward to the plots. So for the eigenvalues for n is equals to 1, 2, and 3 and 4. So in the y-axis, I use En in joules. It seemed to be, some cursive and italic kind of thing because I have used the dollar signs. So it gives an x by l in the x-axis. Yeah. So this is our legend. So for n is equals to 1, it specify n is equals to 1 for black line with black line, n is equals to 2 with blue line, n is equals to 3 with red line, and n is equals to 4 with purple line. So this is the legend, and this is our graph for the eigenvalues. And now we have also plotted the graph of wave functions. We have choose two rows for this 2 rows and 4 columns for creating our subplot like that, and use blue line to specify the graph of wave functions, and use the red line for the probability density function. So for n is equals to 1, you will be getting this kind of graph. For n is equals to 2, you will be getting this kind of graph. For n is equals to this, 3 is this, and for n is equals to 4 is this. And in the similar manner, the probability density function n is equals to 1 is this, 2 is this is for 3, and this is for 4. So in that way, you have used the analytical method for plotting the eigenvalues, eigenfunctions, probability density function, and determine the probability of finding the particle between the defined region and expectation values.